Assalamualaikum warahmatullahi wabarakatuh. So for chapter 3, shear strength of soil. So before we go detail on the shear strength, I want to introduce to you, there are few terms that you need to understand the concepts. There are total stress, pore water pressure, and also the effective stress. Okay, so pressure and stress. So pressure is force per unit area, while the stress is the pressure that transmitted from the external phase to an internal location within the material. So whatever load or pressure that's from the top of the any kind of material, that pressure or that force or load will transmit into the internal locations of the material. So if you have, this is the load from the 5 kilogram load, and then this load will transmit into the internal element, and then it will keep transmit, okay, all the forces received by the material. So this is the stress that the material will need to receive from the load or pressure at the above layer. For the total stress, so the symbol of the total stress is sigma. We call this symbol as a sigma, right? And the total stress acting at a point below the ground surface is due to the weight of everything lying above, whether it's soil, the weight of the soil itself, okay, the weight of the water, and also the weight from the surface loading. So the total stress is due to all pressure on the soil sample. Alright, so if you can see here, that is the soil or overburden pressure. Alright, so let's say we have at this point, we want to identify the total stress at this point. So this point will receive all the loads above this point, meaning that if it is located in here, so there are layer of soil in here. In this layer is already the soil. So the weight of the soil itself is called as a overburden pressure. Alright, the weight of this soil itself above this point, above this point is actually the overburden pressure. Alright, so in this case, if you look at this diagram, at the ground surface, on top of the ground surface, there is no other loads. There is no structure. There is no water level in this soil layer. Just only the soil weight itself. So at any kind of any point of the soil within or underneath the ground surface, so we'll have the total stress based on the overburden pressure. So let's say you want to know the total stress at this point. So due to the depth, now we have the overburden pressure from the above layer. Okay, at this point, it will receive the weight of the soil above this point. So that is the overburden pressure. If you have any loading on top of the ground surface, so this structure juga will contribute to the total stress, because the force here or the load from the structure will transmit to the ground surface, and then from the ground surface will transmit into the underneath the ground surface. Okay, so as mentioned in the previous slide, that the total stress include all the pressures on top of the soil element. Alright, so it's including the weight of the soil itself and also including the weight of the water. Alright, as you can see here, okay, let's say this is one of the point of the soil sample that we zoom out to this element. So you can see that in this body of soil, you have the solid particle. Okay, the yellow one is the solid particle. And then in between the solid particle, all right, there is a pore, or there is an area that we call it as a void. and that void is actually can be filled up by air or water. So if it is filled up by water, so that water inside the void in this soil element, we call it as a pore water. All right. So the pressure that receive from the on top of the soil will also transmit to the water. So this water also will receive the pressure, and we call it as a pore water pressure. So for the total stress will consider all the weight, including the weight of the water. Okay, as you can see here that for the vertical stress and horizontal stress, okay, we have the vertical stress, all right, and also we have the horizontal stress. All right, so the horizontal stress is actually also from the weight of the soil, the self weight of the soil, all right, and the overburden pressure. So in the total stress, it will include all the element, including the pore water pressure. So how to analyze the total stress? Okay, how to analyze for the total stress in the ground? So there are three cases here that we can consider. The first case is when you have any no surcharge. So surcharge including the external load from the structure, for example, right, on the ground surface. If there is no structure, means there is no surcharge. Right. Okay. So for the case of no surcharge, and let's say we want to identify the total stress at this point. Okay. So how to get the total stress is actually from the unit weight of soil itself, and then we need to time with the thickness or the height of the point till to the ground surface. So this is a total stress due to the overburden pressure only. Okay, from the weight of the soil itself. And if we have the groundwater table, okay, and we have the groundwater table above the ground surface in this case, all right, so you can see that we have the groundwater table. It looks like flooded area. Okay, so knowing that we have the groundwater table here means that the soil below the groundwater table is in the conditions of saturated or in the conditions of wet, because there is a existence of water. And we need to identify the height of the water or the thickness of the water level uh, above the ground surface in here. And then we need also to consider the gamma saturated of the water. Because why we need to use saturated? Because now the conditions of the soil of the ground is in wet condition. So that's why we will have this kind of equation, because the total stress due to the overburden pressure here and also hydrostatic pressure. So when due to the hydrostatic pressure, so you will have unit weight of water, gamma water, times with the height of water. And for the overburden pressure, since it is in wet condition, we need to consider the gamma saturated times with the H. And if you have the surcharge load, which is Q, alright, so for the surcharge load means that you have an external loading on the top of the ground surface. So we need to consider the surcharge load. So we can use this equation, alright, which is the total stress is equivalent to gamma H due to the overburden pressure here, okay, the weight of the soil itself, and plus with the surcharge load.